Hello, we'll be starting the chapter Acids, Bases and Salts. For detailed syllabi, you please refer to the respective ICSE and CBSE websites. This is the concept map of acids, bases and salts, whatever we'll be discussing as a part of this discussion, that is summarized over here. This is the pH scale, which is called power of hydrogen. pH means power of hydrogen. This shows different pH of acid, neutral and alkaline material, alkaline or basic material. This will be discussing elaborately in due course of time. These are different content of different acids in our common household items. This is vinegar, this is aspirin, this is vitamin C, this is lemon and this is spinach. So Lavoisier and Davy studied the terms acids, bases and salts. The acid word is derived from the Latin word acidus means sour. It should compulsorily have hydrogen. H plus or hydrogen ion is present in the form of H2O plus when dissolved in water. It turns blue litmus red. So acids are defined as the compounds which contain one or more hydrogen atoms, and when dissolved in water, it produces hydronium ions, the only positively charged ions. Common examples are hydrochloric acid, sulfuric acid, nitric acid, acetic acid. Acetic acid is generally termed as carboxylic acid. It comes under the category of organic acid. So this produce ear-seeing pain in a wound, taste sour, feel rough between the fingers, colorless when placed in phenolphthalein. This you should learn. This is an indicator. In pH portion, we will be learning this about this indicator. These are red on blue litmus paper, means this turn blue litmus red. Blue litmus is also a pH indicator. Acids should have pH less than 7. They produce hydrogen gas when reacted with metals. They produce carbon dioxide when reacted with carbonates. Common examples are given over here. According to the ionic theory, acid is a compound which when dissolved in water yields hydronium ions, that is H2O plus, as the only positively charged ions. You can see the reactions over here. HCl plus H2O gives you ultimately H3O plus plus Cl minus. How it happens? First H plus and Cl minus are formed. Then H plus reacts with water to give hydronium ion. This you had seen in the bonding chapter also. So similarly, when sulfuric acid, nitric acid, acetic acid are dissolved in water, they give sulfate ion, nitrate ion and acetate ion respectively. For simplicity, we will use the simplified form, that is H plus instead of H3O plus. Now come to the classification of the acids. On the basis of the sources, we have inorganic acids and organic acids. Inorganic acids are generally derived from the minerals. They do not contain carbon except carbonic acid. They are strong acids except carbonic acid. They generally completely ionize in water, producing high concentration of hydrogen ion or hydronium ion. Carbonic acid H2CO3, which is commonly found in the carbonated soft drink like your general Coca-Cola Thumbs Up. This is weak mineral acid, has all characteristics of the acid over here, but it is non-corrosive. Other inorganic acids are corrosive. Organic acids are usually derived from plants, contain carbon and hydrogen, weak, do not ionize completely, so contain both ions and molecules in the water. On the basis of oxygen content, we have oxyacids and hydracids. Oxyacids contain oxygen along with hydrogen and other elements. Examples are given over here: sulfuric, nitric, acetic. There are many more. Hydracids contain hydrogen and any non-metallic element. Examples: hydrochloric acid, hydrochromic acid, etc. On the basis of the concentration of the acid, we have concentrated and dilute acid. This concentration of an acid is the amount of acid present in a definite amount of its aqueous solution. In concentrated acid, there is very small amount of water or no water at all. In dilute acid, it contains more amount of water than the concentrated acid. Now for making the dilute acid or doing the dilution of an acid, acid should be poured in water in small amount and with continuous stirring. Water should not be added, that is reverse should not be done. Water should not be added in the acid because the process being the exothermic process, there may be the splashing of the acid solution and this may be fatal to the person because the container in which the reaction takes place, that may also break due to the excessive generation of heat. Now strength of an acid can be measured by the amount of hydrogen ion or hydronium ion produced by the acid in the aqueous solution, and this strength depends on the degree of ionization alpha and the concentration of hydronium ion. So degree of ionization can be given as number of acid molecules ionized divided by total number of acid molecules present in aqueous solution into 100. Now if alpha is greater than 30% for aqueous solution of any acid, base or salt, then those are strong, and if alpha is less than 30%, then those are weak. On the basis of basicity, now basicity is the number of hydronium ion that can be produced by the ionization of one molecule of the acid in aqueous solution. Now from the name monobasic acid, you can always think that there will be the production of only one hydronium ion per molecule of the acid. Example is hydrochloric acid. Now HCl contains one hydrogen ion. So you can easily say HCl is monobasic acid. Other examples are nitric acid, acetic acid, hydrochromic acid. Now in acetic acid we have total 4 hydrogen, but the acetic acid is monobasic acid because in acetic acid COOH is the acid group or organic acid group, or it is also called carboxylic acid group. Now here this hydrogen associated with COOH is the replaceable hydrogen. Actually the basicity is the measure of the number of replaceable hydrogen in the acid. So in case of HCl, this is the replaceable hydrogen. In case of HNO3, this is the replaceable hydrogen. In case of hydrochromic acid, this is the replaceable hydrogen. And in case of acetic acid, this is the replaceable hydrogen. And since this number is 1, it is monobasic and it gives acetate ion and 1 hydronium ion. So monobasic acids produce normal salt when it reacts with base or alkali. This is also called alkali. You will also come to know about base and alkali in the next chapter. Dibasic acids on ionization in water produce 2 hydronium ion per molecule of acid. Here the examples are given. The phosphorus acid is the exception, which we will discuss later. Now dibasic acid ionize this as follows, and they give 1 acid salt and 1 normal salt because it has 2 replaceable hydrogen ion. Now in case of acid salt, we have 1 hydrogen in the salt. In case of normal salt, we don't have any hydrogen in the salt. Tribasic acids on ionization in water produce 3 hydronium ions per molecule of the acid. Examples are given. Now tribasic acids have 3 replaceable hydrogen ions, so they form 2 acid salt and 1 normal salt. Now first acid salt is known as monosodium dihydrogen phosphate. Second acid salt is known as disodium hydrogen phosphate, and normal salt is called trisodium phosphate or sodium phosphate. Now why phosphorus acid is a dibasic acid? As I told you already that the basicity of an acid is dependent on the number of replaceable hydrogen ion. Now here we have only 2 replaceable hydrogen ion which are attached to oxygen atoms. This hydrogen ion is not replaceable. So phosphorus acid is dibasic acid. Now come to the preparation of the acids. First, very simple reaction between hydrogen and the non-metal, you will get the acid. Second, reaction between water and non-metallic oxide. Now non-metallic oxide, when you have done the definitions in class 8 and class 9, you have already learned non-metallic oxides or acidic oxides are oxides which give acid when dissolved in water. So the same definition you can remember over here. Now in case of nitrogen dioxide, this is also called mixed or double acid anhydride. Now this is also called acid anhydride, SO3, SO2, CO2, P2O5, N2O5, because it doesn't contain any water, so anhydride. Now this nitrogen dioxide, when reacts with water, it gives HNO2 and HNO3. That means nitrous acid and nitric acid. That means it gives two types of acid. So these are also called mixed or double acid anhydride. Next is by oxidation of non-metal. This is a very strong oxidizing agent. Sulfur plus nitric acid gives you sulfur dioxide and sulfuric acid and phosphoric acid and corresponding nitrogen dioxide. So you are getting sulfur is directly converted into sulfuric acid, phosphorus is directly converted into phosphoric acid. Now by displacement, salt plus less volatile acid, we will get more volatile acid and another salt. So this is a process by which you can form or you can produce a more volatile acid from the less volatile acid. This type of questions come in the main examinations. Now the properties. Physical properties, tests. Acids have a SOR test. Mineral acids like H2SO4 and HNO3 should not be tested because they are very corrosive in nature. You should not touch even these acids. Physical state, this may be liquid or solids. Some of them are shown in the below mentioned table like boric acid, solid, citric acid, oxalic acid, phosphoric acid, tartaric acid. Liquids are acetic acid, carbonic acid, hydrochloric acid, sulfuric acid, nitric acid. Now towards the indicator how they react. Indicators, what are indicators? Indicators are complex substance, those acquire separate color in acids and basic mediums. Now indicators are blue litmus, red litmus, methyl orange, phenolphthalein, red cabbage water. Colors are given over here, colors in base are given over here, and neutral solutions are also given over here. Now acidic solutions are generally good conductors of electricity, so they are also called electrolytes. You have to remember these indicators and their respective colors in due course of time. So start learning from now. This is also some more indicator colors are given, right? Red cabbage water, red onion water, turmeric water, phenolphthalein, bromomethylol, bromethylmol blue, red litmus, blue litmus, universal indicator. Reaction with active metal. These are now chemical properties. Dilute H2SO4 or dilute HCl when react with the active metals like potassium, sodium and calcium, there is the explosive reaction. If you go for less active metal like magnesium, you will get magnesium chloride and hydrogen, zinc, zinc chloride and hydrogen, Fe, FeSO4 and hydrogen. Now from this you can find out with respective acids also. Here magnesium reacts with HCl, here HCl, here iron reacts with H2SO4. Now HNO3 is very powerful oxidizing agent, so not used for the preparation of hydrogen. This you have already learned in class 9 because it converts hydrogen into water. But with 1% nitric acid, magnesium and manganese produce hydrogen. Next is when acids react with bases, they give salt and water. This is called neutralization reaction. This also you had gone through in class 8th and class 9th. Now reactions with bicarbonates and carbonate. This is calcium carbonate, HCl, gives you salt, water and carbon dioxide. With calcium bicarbonate, the same, salt, water and carbon dioxide. Now lead nitrate does not react with either HCl or H2SO4 as the salt produced, lead chloride or lead sulfate are insoluble. Hence, though the reaction starts initially, it does not proceed after a certain period of time. Now with bisulfides and sulfides and bisulfides, the acids give you sulfur dioxide. When reacts with sulfides, the acids give the hydrogen sulfide, which have a rotten egg-like smell, and the corresponding salt. If this react with chloride, now this is the reaction for HCl preparation in the laboratory. So this you have to learn this is very important for you. NaCl plus H2SO4, concentrated H2SO4 below 200 degrees Celsius gives you the acid salt and HCl, and above 200 degrees Celsius it gives the normal salt and HCl. Now this reaction is the reaction for laboratory preparation of HNO3. Now nitrates generally do not react with dilute acids. Lead nitrate reacts with both dilute HCl and dilute H2SO4, forming PbCl2 and PbSO4, and both insoluble respectively. In case of potassium nitrate with concentrated sulfuric acid, below 200 degrees Celsius it gives the acid salt, and above 200 degrees Celsius it gives the normal salt and nitric acid. Now this reaction is the process of laboratory preparation of nitric acid. So here this also to be learned very specifically from now. These are the uses of acids. Some acids are given over here. Citric used for preservation of food, tartaric used in baking powder, boric acid is an antiseptic, carbonic acid in aerated drinks, acetic acid is used as vinegar, oxalic acid used to remove ink stain, hydrochloric, nitric, sulfuric are used as laboratory reagents. Thank you so much. Subscribe my YouTube channel for more videos. Thank you.